Okay, Calc babies, you're back. Chapter 3, Section 1. So this is the second part. Now, we left off that last video. I went through a 5-step process for how to find extrema on a closed interval. And what I'm going to do is I'm just going to give you a few more looks, right? A few different examples. For each, I've taken the liberty of already finding the derivative for you, right? If that is something you need to touch up on, then you'll have to remedy that on your own, or reach out to me for some resources. But right now, I'm going to have to assume that you can do step 1. All right, well, so let's continue with, so step 2, right? Step 2 was to figure out what the critical numbers are, right? All right, so f prime of x equals 0 or does not exist. That's the definition of the critical numbers that we are going for. So let's start with, let's take a look at our derivative. And let's you and I agree that the derivative, does not exist when x is equal to what? Are you thinking 0? Right? Exactly. Because if you choose x as 0, then you would be dividing this fraction here by 0. Now, what about when f prime of x is equal to 0? Okay, so the derivative does not exist when x equals 0. The derivative equals 0 when x equals, well, let's find out. Well, if you were to choose 1 for x, the cube root of 1 is 1. So you would have 2 minus 2 over 1, or 2 minus 2. Right, so that is when x equals 0, the derivative does not exist. When x equals 1, the derivative is equal to 0. So those are your two critical numbers. All right, now, that third step just says plug in your critical numbers into your original function. So f of 0, f of 1. Let's do the fourth step while we're here. The fourth step just says take your endpoints. Right, I'm going to go ahead and underline it. So -1, +3, those are your endpoints. And plug those into your function as well. So f of -1, f of 3. All right, so let's see what comes out of this. So if you plug a 0 in for your original function, you get back out a 0. If you plug in a 1, you get out a -1. Now, if you plug in a -1, you get out a -5. And if you plug in a 3, you get out, I think this is roughly -0.24. Okay, so I'm gonna go ahead and box these in. And now we're at that last step where you try to find, where you find the min and max. Okay, so use that, what I've boxed in, use those 4 y values. And we'll start with the minimum. So what's the smallest number out of those 4? You got it, -1. That's the smallest y value. Oh, did I really do that? Did I really just do that? Let me try that again. The smallest number is actually -5. By the way, just in case you didn't know, I know you're in calculus, but just in case you didn't know that -5 is smaller than -1, now you know. So what is the smallest number? It is -5. And where does that occur? That occurs when x is -1. That's what I goofed up on. Okay, so now we're guaranteed a min, we're guaranteed a maximum value as long as it's closed interval and those conditions apply. The largest number, and get this right this time, I don't want to make any silly mistakes, that the largest y value is 0, right? And that occurs when x is 0. So there you go. So what I'm going to do now is we're just going to do another example. I'm going to go through another example with you really quickly. And again, I'm going to provide the derivative for you all up front. Okay, ready? And let's jump in. So this would be step 1, right? Take that derivative. So it says find the extrema of 2 sine of x minus cosine of 2x on the interval from 0 to 2 pi. All right, so we went through, we took the derivative. I want to make sure I did that correctly. So the 2 cosine of x minus negative 2 sine of 2x. And that double negative is the positive, so it should be 2 sine of 2x. Okay, so I'm assuming that you can figure out how to take the derivative. And now we want to know, when does the derivative equal 0? Or when does the derivative not exist? Okay. Okay, so let's answer the latter. So look, cosines and sines, they are continuous throughout the entirety of their domain, right? There's no x value there's no angle that you're not allowed to choose. You're good. Now tangent's a different story, right? Because tangent is a quotient of sine over cosine, but cosine and sine, they are defined over the domain negative infinity to positive infinity. So I'm going to answer the question, when does the derivative not exist? And I'm just going to put not applicable. Okay, doesn't apply here. All right, well then let's answer the question, when does the derivative equal 0? Okay, so let me go ahead and give myself a little bit of space here. So let me rewrite the derivative. F prime of x is equal to 2 cosine of x plus 2 sine of 2x. All right, so how do we figure out what x values would cause that derivative to equal 0? Well, let me employ a little identity that's going to be useful here. So the double angle formula, sine of 2x, right, is defined as 2 sine of x cosine of x. Okay, so this is just your double angle formula. And what I'm going to do is I'm going to transform this sine of 2x into, so you can imagine I'm substituting. I'm going to just transform sine of 2x into 2 sine of x cosine of x. So let me do that right now. So that equals 2 cosine of x plus 2, ready? So at this stage right now, I'm going to go ahead and turn sine of 2x into 2 sine of x cosine of x. Okay, so let's go ahead and clean that up. 2 times 2 is 4. And then let me comment as to why I chose to go this route. So remember, we're going to set our derivative equal to 0, right? That's the goal. Now, I want to be able to factor. Unfortunately, the way the derivative was originally written, I had a cosine and a sine. There was nothing to factor. I mean, I could factor out a 2, I agree, but that doesn't help. I need to be able to factor out a function of x. So as soon as I make this, use this identity, make this transformation, do you see that now I can factor out, I can still factor out a 2, but I can factor out a cosine of x as well. So that is going to be extremely helpful. So if I factor out a 2 cosine of x, let's see what's left over. Well, if you factor out a 2 cosine of x from a 2 cosine of x, there would be 1 plus. And if I factor out 2 cosine of x from 4 sine of x cosine of x, that would be 2 sine of x. Okay, you can always multiply, you can always distribute and make sure you did the factoring correctly. All right, so all of this work so that what? So that I can figure out what x values make 2 cosine of x equal 0, and what x values make 1 plus 2 sine of x equal 0. Ready? Let's think about this in pieces. So let's start with the first piece. So 2 cosine of x equals 0. Let's figure that out. And then when we're done there, let's figure out how 1 plus 2 sine of x, how would that equal 0? Okay, so you can, again, you can divide both sides. I'll go ahead and do this for you. You can divide both sides by 2. That leaves you with cosine of x is equal to 0. Now you grab your unit circle and you figure out that when x is 90 degrees, pi over 2, or 3 pi over 2, the cosine value is 0. Now let's do the same thing over here. So I'm going to subtract 1 from both sides. So now I have 2 sine of x is equal to negative 1. And I'm going to divide both sides by 2. Now I have sine of x is equal to negative 1/2. And you know what? You're just going to grab your unit circle again. And now you're looking at, when does sine equal negative 1/2? Well, that's when x is equal to 7 pi over 6 and 11 pi over 6. Okay, I'm with you. Man, that took up a lot of time. Maybe you're thinking, man, that's tough. I don't know, man. Somewhere in the middle of calculus, a lot of people start to reevaluate their plans, right? That, if they were thinking engineering, they were thinking science, and all of a sudden business starts sounding really good. You with me? Hang in there. Come on, hang in there. Somebody's going to pay you a lot of money because why? Because you can do some hard things that not everyone else can do. So hang in there. So pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. Those are your critical numbers. Okay, now what I'm going to do is I'm going to erase all of that little work that I had to do for setting the derivative equal to 0. All right, and then we're going to continue with steps 3, 4, and 5. So if you had to go back and pause the video, rewind it, you'll have to just do that. All right, beautiful. So now we're at step 3, and this is where We're going to do steps 3 and steps 4 at the same time. This is where you're going to plug in your critical numbers. So you got to plug in the pi over 2. You got to plug in the 3 pi over 2. You got to plug in the 7 pi over 6. 7 pi over 6. And you got to plug in the 11 pi over 6. Now, don't forget about your endpoints, right? So that's when I mean the 0 and the 2 pi. You got to plug those in as well. So f of 0, f of 2 pi. All right. I know this doesn't look appealing, but ready? So let's see if we can go through and answer these questions really quickly. So f of 0. Now, as always, look, if you see a silly mistake on the board, it's simply because I don't have my calculator out in front of me. So I believe f of 0 is -1, f of 2 pi is -1, f of pi over 2 is 3, let's see what else we got. 7 pi over 6 is -3 halves. 11 pi over 6 is -3 halves. And then my 3 pi over 2 should be -1. Okay, bear with me. Let's do some uncomfortable silence for just a second. Okay, I just want to, before I do step 5, I want to make sure I didn't do anything silly. Okay. So at this stage, the idea or the game is for you to look at your various y values and make a claim about the minimum and the maximum. Well, let's start with the maximum. So the maximum value that I see is 3, right? Assuming all my arithmetic is correct, then the max is when x is pi over 2, y is 3. Okay? And now let's find the minimums. Right, there might be more than one. In this case, let's see here. -1.5 is smaller than -1, so we would have minimum values at -3 halves. So we have a max at pi over 2, 3, and we have mins. We have two minimums. 7 pi over 6, -3 halves, and 11 pi over 6, -3 halves. Okay, so I think that everything is okay, and you have, at this stage, you got the gist, right? You have the gist on how to find relative extrema. What are the main takeaways? Well, henceforward, when I use the words critical numbers, you should know what I'm doing, know what I'm talking about. You should know that when that the derivative can help you for finding relative extrema. And you should know that if you have a closed interval, that you are guaranteed a minimum and a maximum. And with that, we will conclude.